So hello everybody, welcome back to the channel, and today in this video we are doing some integration. We are doing some integration, calculus, and I'm like right now learning calculus, so this is going to be a cool thing. I'm using a website called Mathska. I hope that's how it's pronounced. And I'm going to be opening up a math container and I'm going to be writing up a question. So this one is going to be indefinite integral. So let me find the sign for the indefinite integral. I don't see it anywhere here. Where is it? Although it is not a big problem, and this site I have found is just, I think, super awesome. Maybe we could like, I can use this. Oh yeah, awesome. Oh, I can like add things, add the upper or lower limits just from here. Now the question is, so let me write up a question. Evaluate the integral. Right, I have to evaluate the integral of 2x times square root of x square plus square root of x squared plus, why is it not working in this way? I need it to be inside of the square root. How do I? Square root of 1 plus 2x, x square plus 2, okay, this works, and 2x. So this is the function we need to evaluate the integral of with respect to x. Now how do we do it? Well, we say, now we look at a few things now. See, the first thing is that the two terms here are in product. And now we don't have a simple product rule in integral, right? In integrations, we don't have simple product rules. So we have to use some awesome ideas in order to solve these questions. And now, since this is the integral of 2x times the root of x squared plus 1 dx, then what we do is we look if we can find the derivative of any term in here just within the question. And in this case, we can see that the derivative of 1 plus x squared is just 2x, right? So what do? We say let y equals to 1 plus x squared, right? Now, and then we say then, can I go back? I cannot. Okay, pretty fine. Then what we do is write dy over dx is equal to the derivative of 1 plus x squared dx, right? So this is the derivative we can get from here. And now this is like a totally separate thing. And now what we do is we say again, the derivative of dy is, now y is like 1 plus x squared, so it's written this way. And now we could directly evaluate the derivative, but for those of you who are new here, I'm going to be writing a bit. So d over dx of just 1, so that's just d over dx plus the derivative of dx squared divided by dx. Right now we have this as the derivative to be calculated. So what do? We say dy over dx is equal to, now the derivative of 1, the derivative of any constant is equal to 0 plus derivative of x is 2x, right? So we can say dy over dx is basically equal to 2x, and then we say dy is equal to 2x times 2x dx, right? So this is dy that we have here. Now, why are we doing this? Well, it'll make a sense now because we have dy equal to 2x dx. Now, we have already let a few things. Now, we just copy this question for a while and now start from here, right? So I say this is equal to the integral of, now see, I can rearrange these terms in different ways. So first I say square root of, let's go for x squared plus 1, right? X squared plus 1 times, like, let's go for, how do we write times? I can leave that. The times is like going to be denoted by dot, right? 2x dx. I'm just rearranging these terms, right? So rearranging these terms, and then that's going to be equal to the integral of square root of, now what is x squared plus 1? Well, this x squared plus 1 is equal to y, as we have already let it here. So it's going to be the square root of y, right? Now it's going to be times square root of y times, now what is 2x dx? Well, if we look properly, we see that 2x dx is equal to dy. Okay, let's write equation 1, right? Just to make it beautiful. Okay, let's make it equation 2, and then let's make it equation 1. Now we say here, after this, values of this and from equations I and double I respectively. So we are replacing the values of these things, or these terms from the equations 1 and 2 respectively, and then we can like substitute these values, and to be more precise, this statement goes after this one, right? So now we are in track. So after we have done this, now what do? We say dy. So this is equal to the integral of y to the power, what was that? 1 over 2, if you can see that properly. So it's equal to y raised to the power 1 over 2. Okay, let me write it in a better way. 1 over 2. Oh, that doesn't go well. Y raised to the power, 1 over 2. So y to the power 1 over 2 and dy. So what does this get equal to? Well, this is equal to, now we can simply use the power rule from here, and the power rule states, let me write up here, just over here, power rule. The power rule says integral of x raised to the power n dx is equal to integral of x raised to the power n plus 1 divided by n plus 1. plus c, which can be any constant, right? So this is the power rule for integration. And okay, let me write the power rule for the derivatives as well. So for derivatives, the power rule is like dy over dx. Let's say not by for now. I don't want it to be written so long, but dx to the nth power, right? Dx to the nth power with respect to x is going to be n times x raised to the power of n minus 1. Simply, this is the power rule for derivatives, and this is the power rule for antiderivatives, right? So we have come to this step, and from here we can see that this is equal to y raised to the power now 3 over 2. Okay, let me write it for you guys. 1 over 2 plus 1. This is all going to be in a fraction divided by 1 over 2 plus 1, and then plus c, which is a constant, right? So how do we get this? Well, this comes from the power rule, as you already see that the y here is equivalent to the x over here in the question. So, and not in the question but in the power rule, whatever role x is playing here, well, y is also playing the same role over here. So we have a constant power, which is also here, n plus 1, so we use this formula. C is the constant of integration, which can be like, a constant, so we use that one. So now we get it equal to the fraction y raised to the power 3 over 2 divided by 3 over 2 plus c, if we add these things up, right? So if we rearrange the terms now, we get it equal to 2 times y raised to the power 3 over 2. Let me write it just in the normal way. Okay, I'll write it for you guys. 3 over 2 and inside of a fraction over 3, right? And then plus c, which is going to be now replaced. Now we can say this is a fraction 2 times, what is y? Well, y is simply 1 plus x squared. We had like substituted the value, right? So in place of y, we are going to be writing out 1 plus x squared, because we are in the question initially we have to we have to integrate this function with respect to x, and x is the variable, so we cannot leave it in terms of y. So finally the answer should be in terms of x, because the question is in terms of x, and the question does not know what y is. Y is just for our convenience to integrate. So 2 times, how do I write this? Yeah, 2 times 1 plus x squared, right, divided by 3 plus c. So this has to be raised to a power of 3 over 2. So this is the final value of the integral of 2x times the square root of 1 plus x squared dx. So this is the way with which we can do this. And now if you guys want to check how this is the integral, how is this the correct answer, then what you have to do is, well, you can differentiate this function again, right? If you want to differentiate this function, and then you get something like you get this, and what you can say is That's correct. Right? Now I'm going to be showing you by differentiating this function as well. So copy this. Let's write differentiating the function which we obtained as the answer to the integral to the integral this in order to cross check and verify whether or not what we obtained as the answer is correct and valid or not. So we are using this. I cannot use the exclamation mark for formal writing. Right now, oh, we could like make up statements in these. So this is like awesome. I didn't know that. Oh, what happened? Okay, thank God. Okay, done. Look at this. Just forget about this. Okay. So we are now going to be differentiating this function. So let y math container let y is equal to this. Right? Now we are letting this equal to y, and do not confuse this y to this y, okay? You should not confuse these two. So this is like a simple question. Now what you have to do is like now differentiating both sides with respect to x. So we differentiate both the sides with respect to x, and again we have to write here as well. Differentiating both sides with respect to x. Right now we differentiate these two sides with x, we get dy over dx equals to d fraction d over dx of just this thing. Right now it looks a bit big and just overwhelming, but it's not a problem to be worrying about for us. I want to use some big brackets now. That's important. I hope these can cover things up. Oh yeah, this is what I wanted. Right now we are going to be differentiating the function, which is a fairly simple task. We just say is equal to d over dx of let's use the we don't have to necessarily use this, but still, okay, I'm writing it for you guys. From the next questions I'll not be writing these things, alright? Plus fraction d over dx of c. Right now this is a simple thing, and then we say dx, and again here dx. Oh sorry, we're differentiating right now, right? So I thought we were integrating. So this is what we have, and well, if you guys are wondering about what might the value of c be, because we don't know what the value of c is, well, we don't have to care about it, because whatever it is, the derivative of c is just going to be 0, so it's just there was a word in English I forgot. It's just omitted, right? It's just omitted, so we don't have to care about c, because the derivative of any function that's giving a constant result is just 0. So this is equal to fraction 2 over 3 d over dx of what? Well, this. So this is equal to 2 over 3 times the derivative of 1 plus x square raised to the power of 3 over 2 plus 0, because the derivative of any function that's constant is just 0, and that becomes, now if we look very carefully, we have gotten into a situation that's kind of not so good. We write it in proper notation, 2 over 3 times, again, I think we're doing this, d over dx of 1 plus x square raised to the power 3 over, 3 over 2. Now, in this situation, what do we do? Well, for example, if you wanted to use the power rule, right? If we wanted to use the power rule, which is up here, it should be in a format of x raised to the power n. Well, we have the power n over here. That's not a problem, but this is not x, right? This is not x, and if we look at the power rule for derivatives very carefully, this x has to be equal to the variable with d on the denominator. And if we look at this case, if we suppose this is x, then this is not equal to this x. So what has to happen is this thing has to be equal to what is in product with d on the denominator. So in order to make these equal, we make these equal, right? So frac 2 over 3 times d times frac d over, so d over dx of just this thing. Right, now, see, we cannot use the chain rule directly, so since this thing has to be equal to the x over here, we cannot change this to be x, because that would just take the question out of everywhere. So the coefficient of the power, right, the variable or the constant, whatever it is, whatever has the power has to be equal to the variable with product, which is in product with d on the denominator, and it cannot be a constant because it's not making any sense. So we have to have something like this, right? d over d of 1 plus x squared times, I pronounce it that way, 1 plus x squared raised to the power of 3 over 2. Now, if we have just replaced the x by this, then where is the x? Well, it is just over here, right? It is just over here, x, right? So dx. And now, if we multiply something on the denominator, we have to multiply the same thing on the numerator to balance it up. Now, if we do this, everything is balanced. For example, if we cancel these two, then we just get up and, end up in the same situation like this. So, just looking at it mathematically, there's no difference. So, this is going to be 2 over 3 times, now we can use the power rule. So, the derivative of x raised to the power n is, well, just n times x raised to the power n minus 1, isn't it? So we can use that, and that would be so awesome to be using. What? Does that make sense to speak? Alright. So go to frac and say 3 over 2, because that's n times, what is the x over here? X from the formula, not the x in the variable sense, raised to the power n minus 1. Well, that's 1 over 2, isn't it? So we have to use that sort of logic. So 1 over 2. And again, that's going to be multiplied, and I think it would be better if I had written this in, okay, no problem. It's going to be multiplied with the derivative of, now we can use the big braces, 1 plus x squared dx, that's going to be just 2x, because the derivative of 1 is just 0. So these are going to be multiplied, and then if we look carefully, these things, all these are going to be cancelled, because, like, you get it, right? So this is going to be 1 plus x squared raised to the power let's write it in a square root. That'd be good, right? So because if it's 1 over 2, then that's just the same thing, times 2x. And I can rearrange this as 2x times the square root of 1 plus x squared, which I can be writing as x squared plus 1 as well. We write it as x squared plus 1, that looks a lot better. Plus 1. So this is what we get by differentiating this function or this thing, whatever you call it. And the output that we get after differentiating the output of the integral is equal to the question of the integral, which is just this, isn't it? See, look at this function. 2x times the square root of 1 plus x squared, 2x times the square root of 1 plus x squared. So this is absolutely correct. Whatever we did has no mistakes at all, and this is the way to do it. And there might be other ways as well, but what I used is also correct, and this is so awesome to use and do. So with this, we have gotten a good concept of derivatives, I hope. So if you guys liked the video, then I just want you to subscribe to the channel, which would be so awesome. And yeah, so I'll meet you guys in the next video. Till then, you just, watch this video, and goodbye.